We'll start in about a minute. Today we'll start Chapter 9, Section 1. This section is how to solve quadratic equations by using the square root property. First, we'll see a definition of a quadratic equation that's in standard form. The standard form of a quadratic equation in the variable x is ax to the second plus bx plus c equals 0. There's supposed to be an equals 0 there, where a, b, and c are constants and a does not equal 0. So just to reiterate, it's an equation, so there's an equal sign and something on both sides. So on the right-hand side is 0. This is the standard form for a quadratic equation. Here's some examples of quadratic equations in the variable x that are in standard form. This is just an example, 3x to the second minus 2x plus 1 equals 0. So in this equation, a is 3, b is negative 2, and c is 1. The other example, negative 2x squared plus 7x minus 5 equals 0. In this quadratic equation, a equals negative 2, b equals 7, and c equals negative 5. Quadratic equations not in standard form can be written in standard form. So let's do that with these equations. Write each of the quadratic equations in standard form. So we want the term with the largest exponent on the left, farthest to the left, so 5x to the second. And then negative 2x, that's equivalent to subtracting 2x. And then we're going to add 7 to both sides of that equation so that the right-hand side is 0. So this is the standard form. And the next example, negative 4x squared plus 9x equals negative 12x. We can get this into standard form if we add 12x to both sides and write it as negative 4x to the second plus 12x plus 9 equals 0. You should be aware that every quadratic equation can be written in standard form in one of two ways. So this one, negative 4x to the second plus 12x plus 9 equals 0. If I multiply every term on both sides by negative 1, the standard equation will look different, but I'll mention one of the things that won't be different. So if you multiply both sides by negative 1, So negative 1 times negative 4x squared is 4x squared. Negative 1 times 12x is minus 12x. And negative 1 times 9 is minus 9. Negative 1 times 0 on the right-hand side is still 0. Okay, so these aren't literally the same equations, but the two equations have exactly the same solutions. So that is the main thing that I want to point out with this example. Those two equations have exactly the same solutions. So I'll just say the two equations have the same solutions. So in my opinion, that's useful information because also in my opinion, solving a quadratic equation that's in standard form is generally easier if the coefficient of the x squared term is positive. You can leave the coefficient of x squared negative if you want, but the arithmetic involved will be a little bit trickier because of that leading negative coefficient. So you can avoid that by writing the standard equation so that the coefficient of x squared is positive. It's not required, but it's, in my opinion, less problematic. Okay, to write this one in standard form, we can add 8x squared to both sides and subtract 6x from both sides. So we get 8x to the second minus 6x minus 7 equals 0.
Would it be plus 7?
I added 8x squared to both sides, and I subtracted 6x from both sides, and then I already had a minus 7 or a negative 7. Yep, I believe this is correct. Okay, on the next page, we'll look at the square root property. Okay, the square root property. If x to the second equals k, or k just represents a number, then this equation has two solutions for x. Either x is equal to the positive square root of k, or x is equal to the negative square root of k. And an alternative notation, if x squared equals k, then you can write x equals positive or negative square root of k. Okay, so we'll use this square root property to solve some quadratic equations. X squared equals 81. This is a quadratic equation. There isn't an x term, but just as an aside, you could write this as x squared plus 0 times x, and then minus 81 equals 0. So this equation is the standard form for this one. But whenever the coefficient is 0, you don't need to write the term. Okay, if you think about what the solutions to this equation are, if x squared equals 81, can you think of a number that you can replace with x that will make that equation true? Another way is to ask, what number would I have to to raise to the second power in order to get 81. Yeah, I can use 9. If I square the number 9, I get 81. Is that the only solution? No, there's another solution. What's the other number that you can square to get 81? -9. If you square the number -9, -9 times -9 is also 81. Okay, so we can find the solutions to this one just by thinking about what I would have to square in order to get 81. But if we apply the square root property, if x squared equals 81, then the square root property says the solutions are x equals positive and negative square root of 81. But the square root of 81 is 9, so x equals positive and -9. So just remember, this represents two solutions. One is +9, the other one is -9. If you want to list the solutions separately, you can. You can say x equals 9 and x equals -9 are the solutions. Okay, the next one, y to the second equals 13. Apply the square root property. Well, if y to the second equals 13, I just start out by writing y equals positive and negative square root of 13. The square root of 13 cannot be simplified further, so we just leave it like this. But once again, if you want to write the solutions separately, you can. Y equals the positive square root of 13 and y equals negative square root of 13 are the two solutions. Okay, we will progressively get a little more challenging as we go. Okay, the next equation, we have the binomial y plus 3 squared equals 16. Since we have a quantity squared equals a positive number 16, we can apply the square root property directly to this. So when we apply the square root property, we get y plus 3 equals positive and negative square root of 16. We want to solve for y, so in the next step, we're going to subtract 3 from both sides. The conventional way to do that is to write -3 plus and minus the square root of 16. The square root of 16 is 4. So we get y equals -3 plus 4, and then -3 minus 4. But we can simplify further because in one case, y is -3 plus 4 or +1. And in the second case, y equals -3 minus 4 or -7. So -7 and +1 are the two solutions. And as always, if you want, you can check your solutions in the original equation. Okay, the next one, this time we have the binomial x minus 5 squared equals 17. We can apply the square root property to this directly. So if the quantity x minus 5 squared equals 17, then x minus 5 equals positive and negative square root of 17. We want to solve for x, so we add 5 to both sides. And the conventional way is to write it this way: x equals 5 plus and minus the square root of 17. If you want to write the solution separately, then just write x equals 5 plus the square root of 17. The other solution is x equals 5 minus the square root of 17. Okay, the next example, 49x to the second equals 169. We can go about this in a couple of ways. Since 49 is a perfect square, we could just apply the square root property to this. And if we do it that way, the square root of 49 is 7, the square root of x squared is x. So we could write 7x equals positive and negative square root of 169, which is 13. And then divide both sides by 7, we get x equals positive and negative 13/7. Another way to do it is to divide both sides by 49 first. So we get x squared equals 169 divided by 49. And then apply the square root property. And we get x equals positive and negative square root of 169 over 49. But both 169 and 49 are perfect squares, so x equals positive and negative 13/7. Okay, in the next example, we have negative 4y to the second equals negative 24. So this time we should divide both sides by negative 4 to start with. So y squared equals positive 6. And then apply the square root property. If y squared equals 6, y equals positive and negative square root of 6. If you want to write them separately, write them as y equals the square root of 6 and y equals negative square root of 6 for the two solutions. Okay, the next two examples are similar to ones we've already seen. So it's just more practice. The binomial y plus 4 squared equals 25. To solve for y, we can apply the square root property. And we can write y plus 4 equals positive and negative square root of 25. And then y equals negative 4 plus and minus 5. And we can simplify further. One solution is negative 4 minus 5, or negative 9. The other solution, negative 4 plus 5, or positive 1. So negative 9 and positive 1 are the solutions. Okay, the next example, x minus 7 squared equals 29. So this is all set up to apply the square root property. So x minus 7 equals positive and negative square root of 29. then add 7 to both sides, x equals 7 plus and minus the square root of 29. Written separately, one solution is x equals 7 minus the square root of 29. The other solution is x equals 7 plus the square root of 29. Okay, so more of the same on the next page. Only slightly more complicated. Okay, solve this. Solve the equations using the square root property. X squared minus 45 equals 0. So work on that for a few seconds and then type in your answer. Well, on this one, x squared minus 45 equals 0. First, we have to add 45 to both sides. So x squared equals 45. And then apply the square root property. X equals positive and negative square root of 45. The square root of 45 can be simplified further. The largest factor of 45 that's a perfect square is 9, so we can rewrite the square root of 45 as the square root of 9 times the square root of 5. And then finally, x equals positive and negative 3 times the square root of 5. The solutions written separately, negative 3 times the square root of 5, and the other is positive 3 times the square root of 5. Okay, the next example, we have 3 times the binomial x minus 4 squared equals 150. So divide both sides by 3 first. So we get x minus 4 squared equals 50. And then apply the square root property. So we have a binomial squared equals 50. So the binomial x minus 4 is equal to positive and negative square root of 50. So we have a couple of things to do. Simplify the square root of 50 and also add 4 to both sides. So we can do both of those at once. We can add 4 to both sides, so we get x equals 4 plus and minus. And then the square root of Square root of 50, think of that as the square root of 25 times the square root of 2. And then the square root of 25 is 5, so x equals 4 plus and minus 5 times the square root of 2. The next example, slightly more complicated, but not too bad. We have a binomial 7x plus 1 squared equals 48. So this is all set up to apply the square root property. So we start by writing 7x plus 1 equals positive and negative square root of 48. So 3 things to do. One of the things is simplify the square root of 48. And then we're going to subtract 1 from both sides. And then the last thing we'll do is divide every term on both sides by 7. So we can start by writing, we can subtract 1 from both sides, and then also work on simplifying the square root of 48. So 7x equals negative 1 plus and minus the largest factor of 48, that's a perfect square.
Square root of 16 times square root of 3.
Anybody online? What's the largest factor of 48 that is a perfect square? Maybe they're watching cartoons. Now, the largest factor of 48 that's a perfect square is 16. 16 times 3 is 48. So rewrite the square root of 48 as the square root of 16 times the square root of 3. Well, before dividing both sides by 7, I'll just simplify this a little more. 7x equals negative 1 plus and minus 4 times the square root of 3. And then finally, divide everything on both sides by 7. So x equals negative 1/7 plus and minus 4 times the square root of 3 divided by 7. An alternative way to write the right-hand side, you can write the numerator as negative 1 plus and minus 4 times the square root of 3, and then divide everything by 7. So make sure you get into the habit of writing a complete division bar. If you only write a division bar that's below the 4 times the square root of 3, but not the negative 1, then that's not a correct way to write it. So either of these is okay. Okay, the next one is similar type of process. We have the binomial 8y plus 5 squared, and that's equal to 50. So we apply the square root property, and we get 8y plus 5 equals positive and negative square root of 50. In the next step, we'll do two things. We'll subtract 5 from both sides and write it as -5 plus and minus. And then we'll begin simplifying the square root of 50. The largest factor of 50 that's a perfect square is 25. So the square root of 50 is equivalent to the square root of 25 times the square root of 2. Then 8y equals -5 plus and minus 5 times the square root of 2. Then divide everything on both sides by 8. So 8y divided by 8 is y equals -5 plus and minus 5 times the square root of 2, all divided by 8. Okay, on the next page, solve the following equations using the square root property. So this example is a sort of premonition of things to come. That's an appropriate word this close to Halloween, right? An omen. So we don't see a binomial squared. We see that there's a y squared term. So what are we going to do? Well, let's subtract 3 from both sides. So we get 3y to the second minus 2y equals 0. And then let's divide every term on both sides by 3. So when we divide every term on both sides by 3, we get y squared minus 2/3 y. 0 divided by 3 is 0. Okay, what we're going to do next, now that the coefficient of y squared is 1, and we have a term with y in it, we're going to create a perfect square trinomial by adding an appropriate number to both sides of the equation. So remember what a perfect square trinomial looks like? They can have a couple of forms. One is a to the second plus 2ab plus b to the second. This is called a perfect square trinomial because the two factors are identical, a plus b times a plus b. The other form of a perfect square trinomial is a to the second minus 2ab plus b to the second. The two factors of this are also identical, but the two factors this time are a minus b times a minus b. So when the coefficient of the squared term is 1, and then the y term is present, and we have no other term here on the left-hand side. We can always create a perfect square trinomial out of that. So that's what we're going to do. We're going to create a perfect square trinomial. We're not going to do anything illegal. We're just going to find a number to add to both sides of the equation so that the left-hand side is a perfect square trinomial. And if it's a perfect square trinomial, then we can write it as a single binomial squared. Okay, so how do we know what number to add to both sides? Okay, when the coefficient of y squared is 1, what we do is we compute 1/2 of the coefficient of y. So 1/2 of negative 2/3. Negative 2/3 is the coefficient of y. 1/2 of that is negative 1/3. Then what we do is we square that number. So when we square the number negative 1/3, we get positive 1/9. And this number, 1/9, is the number that we're going to add to both sides of that equation. So add 1/9 to both sides, so we get y squared minus 2/3 y plus 1/9 equals 0 plus 1/9, or 1/9. The left-hand side is a perfect square trinomial. So that means it can be written as a binomial squared. So what binomial would we have to square in order to get y to the second minus 2/3 y plus 1/9? Okay, it's not too hard, and it will get easier with practice. Since the coefficient of y squared is positive 1, the binomial has to have 1y in it. And how do I determine what the number is? Well, this number up here, when we took 1/2 of negative 2/3, we got negative 1/3. So inside the parentheses, we write y minus 1/3. And you can verify that this is correct if you square the binomial y minus 1/3. So why don't we do that? Verify this. If you square y minus 1/3, that means y minus 1/3 times y minus 1/3. So y times y is y to the second, and then minus y times 1/3, or minus 1/3 y. And then we have minus 1/3 y again, minus 1/3 y. And lastly, in effect, what we're doing is we're multiplying negative 1/3 times negative 1/3, which is positive 1/9. And then the two middle terms are like terms, so we get y squared minus 2/3 y plus 1/9. Okay, now we can solve the equation by applying the square root property. So I can probably squeeze that in down here. Y minus 1/3 quantity squared equals 1/9. Applying the square root property, we get y minus 1/3 equals positive and negative square root of 1/9. So in the next step, we'll add 1/3 to both sides and also simplify the square root of 1/9. So we get y equals 1/3 plus and minus 1/3. We can simplify further. 1/3 minus 1/3 is 0. And then 1/3 plus 1/3 is 2/3. So I wonder if you noticed that we could have solved this in an easier way. So I have a couple of minutes to spare, I think. Notice when we subtracted 3 from both sides, we ended up with 3y squared minus 2y equals 0. I know we were sort of forced into solving it the way that we did because of the directions solved by using the square root property. But we can solve this equation by factoring. One side is 0, and we factor the other side. The greatest common factor of the two terms is y, so we factor y out, and the binomial is 3y minus 2. Then we set each factor equal to 0, y equals 0. The other factor, 3y minus 2, is 0. Y equals 0 is a solution. And then on this one, we solve for y by first adding 2 to both sides, 3y equals 2, then y equals 2/3. Okay, those are the same two numbers that we got by going through this process of completing the square. So in general, if you're just supposed to solve an equation, solve it in the easiest way that you know how. But if the directions call for a certain procedure, then follow that procedure. Okay, the next one, 3x squared equals negative 75. First, divide both sides by 3, and we get x squared equals negative 25. And then apply the square root property. So we get x equals positive and negative square root of negative 25. Well, we now know how to compute square roots of negatives. So the two solutions are not real numbers, but they are solutions. The square root of negative 25, let's do that on the side. Square root of negative 25 is the square root of 25 times the square root of negative 1, or 5 times I, because by definition, the square root of negative 1 is replaced with the letter I, called the imaginary unit. So the two solutions are the two complex but not real numbers, positive and negative 5i. Here, the next example, the binomial negative 3y plus 4 squared equals 49. So apply the square root property. We get negative 3y plus 4. I don't really need those parentheses, but that's equal to positive and negative square root of 49. So we want to solve for y, so we get negative 3y. We'll subtract 4 from both sides, negative 4 and then plus and minus 7. And then divide everything on both sides by -3. So we get y equals -4 plus and minus 7 divided by -3. Here we can simplify further. So one of the solutions is -4 plus 7 over -3, or 3 divided by -3, or -1. The other solution is -4 minus 7, all divided by -3, or -11 divided by -3, which is positive 11/3. Okay, the next one, the binomial -5x plus 3 squared equals 64. So apply the square root property, and we get -5x plus 3 equals positive and negative square root of 64. Then -5x equals -3 plus and minus 8. Then divide everything on both sides by -5. X equals -3 plus and minus 8 divided by -5. We can simplify further, so we have to do that. X equals -3 plus 8 divided by -5, or 5 divided by -5, which is -1. And the other solution, x equals -3 minus 8 divided by -5, or -11 divided by -5, which is positive 11/5. Okay, in the remaining 3.5 minutes or so, I'll just make up some problems. We'll start to think about what's coming ahead. So let's try this one. Solve 3x to the second plus 6x minus 7 equals 0.
Could you pull down the, yeah.
Solve 3x squared plus 6x minus 7 equals 0 by creating a perfect square trinomial in the process. So doing it this way, you can solve any quadratic equation whatsoever using this process. So what we want to do is we want the x squared term and the x term on one side of the equation. So we're going to add 7 to both sides. So we get 3x to the second plus 6x equals 7. Then we're going to divide every term on both sides of the equation by the coefficient of the x squared term. And when we divide every term on both sides by 3, we get x squared plus 2x equals 7/3. Okay, in the next step, we create a perfect square trinomial. So in the next step, Well, here I'm calling it creating a perfect square trinomial. But you'll also see this expression, complete the square. In the next step, complete the square. So what does that mean? Well, it's synonymous with creating a perfect square trinomial. The idea is if you find a number to add to x squared plus 2x so that it becomes equal to the square of a binomial, then you will have completed the square. But whenever you square a binomial, you get a perfect square trinomial. Okay, so well, we're out of time. Since the coefficient of x squared is 1, we take half of the coefficient of x. So 1/2 of 2 is 1. And then we square 1 and add that to both sides. So x squared plus 2x plus 1 equals 7/3 plus 1. And then x squared plus 2x plus 1 is x plus 1 squared equals 10/3. And then you can use the square root property to solve. Okay, so we're out of time. On Monday, we'll talk more about this particular method.